This video is for Nova Online Math 161 and we are reviewing for the final exam, and the topic of this video is polynomial function. So we have this M-shaped graph given to us, and part A we need to determine the minimum degree of the polynomial based on the number of turning points. So let's see how many times this graph turns. Any relative minimum or maximum, we should count them. So here, that's the first relative maximum at -3. We have another, well, this one is a relative minimum down at 0, about -3.6-ish. We have a point there. And I have another relative maximum up around x value of 4. Okay, so I count 3 turning points. So there are 3 turning points of this graph. Which means the minimum degree is going to be the number of turning point plus 1. It's always going to be the number of turning point plus 1. So this could be a quartic function. To determine the minimum degree of the polynomial based on the number of turning point, we think this is a 4th degree function. Always just count the number of turning points, how many relative minimum or maximums you have, and add 1 to that number of turning points. That's how you can tell the minimum degree of the polynomial. Now let's move on to part B. Part B, we need to determine whether the leading coefficient is positive or negative based on the end behavior, and whether the degree of the polynomial is odd or even. So this question is actually 2 parts. Let's answer the first part about whether the leading coefficient is positive or negative. Now, if you want to answer that part, just look and see what this function is doing to the right end. Okay? So look for the right end behavior. If it's going up to the right, then it's going to have a positive leading coefficient. If it goes down to the right, then it's going to have negative leading coefficient. So don't look at everywhere else. Just look at the right end of this graph. So start somewhere, follow the graph. Where is the graph going to the right? This is going down to the right side. This is an M-shaped graph. So the right end is pointing down. So we know this graph will have a negative leading coefficient. Because the right end behavior is going down to the right. Okay? Now they want us to talk about whether the degree is going to be even or odd. Now that we need to compare the right end and the left end. Look, the right end behavior is down. It falls to the right. Now, what is it doing to the left end? Now, I start somewhere and then I go to the left of that graph. And again, the left end behavior is also going down. This is an M-shaped graph. So both the right and the left end are pointing down. So if the left and the right end behaviors are the same, so see we got down and down, right? We are looking at an even degree function. If they are opposite, we were going to say odd, but when they have the same end behavior, we are looking at an even degree function. So, because the right end and the left end behaviors are the same, this must be an even degree function. Okay, let's look at part C. Approximate the real zeros of the function and determine if their multiplicity is even or odd. Okay, so I'm going to go copy this graph right next to me. I'm going to erase some of these things, okay? Because now we're not looking at the end behaviors or the maximum or minimum, but we're looking at zeros. So I will mark those right here, okay? So what they mean by real zeros, okay, are the x-intercepts. Okay, so plot any x-intercepts that we have here. We have an x-intercept right here. Is there any other x-intercept? We have another x-intercept here at 2. And then the last x-intercept is at 5. So we have 3 x-intercepts. One at -3, 1, 2, 3, yep. And one at +2, and one at 5. These are the places where the graph touches or crosses the x-axis, okay? Now, approximate the real zeros of the function. I'll say the first one is x equals -3. And you know what they say is determine their multiplicity is even or odd. Now, for that part, we have to remember, and I think that's from section 2.2, if graph crosses, then it has odd multiplicity. So I'm going to look at the x-intercept of 2. Take a look. The graph, when it touches the 2, notice it crosses to the other side, right? So to the left of 2, the graph was below the x-axis. But to the right of 2, the graph is above the x-axis. So anytime the graph crosses at that particular x-intercept, what we know is that this 0 will have odd multiplicity. So I'll say odd, not just odd, we'll say odd multiplicity. Now look at 5 too, okay? Notice the 5, the graph was above the x-axis to the left of 5, but when it hit 5, it went to the other side, right? It went below the x-axis. So the graph again crossed to the other side at x equals 5. So what we're going to say is that the x-intercept or the real 0 of 5 must have odd multiplicity. So anytime the graph crosses at that x-intercept, we know the exponent for that factor is going to be odd. So we say those are odd multiplicities. Now look at -3 though. Something slightly different is happening here. So to the left of -3, the graph is below the x-axis, right? Now it didn't go up, right? It hit that -3. And what happened to the graph? It went right back down. So it bounced off and went back to the below the x-axis. So I think our textbook calls it, I can't remember if it was bounces or touches, but it was one of those two words, right? Bounces or touches. So anytime the graph does not cross to the other side, but it just bounced off to where it came from, or it touches it and go back down, then or go back up, depending on where you're coming from. But if it doesn't cross to the other side, what we must know is that this is where the multiplicity is even. So we're going to say at -3, their multiplicity will be even. Multiplicity. And that all depends on whether the graph crosses or not, okay, or touches. And that is how you can tell their multiplicity is even or odd, okay?